The purpose of the mini project 3 was to design a casino game, or more specifically, a casino slot game. To design the game, a linear feedback shift register, or LFSR, was used. The LFSR was a commonly used pseudo random test pattern generator, which uses a linear function as an input. Since this is a casino game, the amount of outputs that would be generated needed to be limited, so the losses that the user will experience will increase based on the seed that was input into the system. To do this, instead of a primitive polynomial, which will generate a full or complete set of outputs, a non-primitive polynomial of the modular or Galois LFSR was used. This would generate a set of numbers that were random but limited to a maximum of 30 outputs and a minimum of 1 output. An example of a linear function that was used for this mini project 3 was px was equal to 1 plus x to the power 2 plus x to the power 3 plus x to the power 4 plus x to the power 7. Since it had a maximum of x to the power 7, this means that a 8-bit binary number would be generated. At each x to the power 2, x to the power 3, x to the power 4, and x to the power 7, a tab was tapped into the position, and these numbers were XOR with the last bit, bit 7, to change the bit output at these positions. This would generate a set of random numbers. Using this method, the programmer could set the seed for the random number generator module to a seed that could only generate it probably lost or try again, or lost or win and try again, or only try again. The try again is dependent totally on the luck of the user, while the win and loss could be decided by the programmer. This would limit the chances of winning a particular game. The seed used for this demonstration was 4-7. 4-7 had a 2 out of 15 chance of winning, 2 out of 15 chance of losing, and 11 out of 15 chance of getting a try again. To demonstrate this video, first I will put the reset to 1, and then I'll put this reset to 0. It was seen just now that the first seed was 4-7. Then I would press the roll button. When I press the roll button, it will go to the control module, which will initiate the RNG module, or the random number generator module, to generate a set of numbers. When I release the button, and this would go directly to an adder module, which will obtain the sum of the 4 least significant bits of the random number generated and the 4 most significant bits of the random number generated, and add those numbers together. The sum would be obtained in decimal. Then the sum of these 2 bits would be sent to the test logic module. The test logic module would determine whether the sum was either a win, lose, or try again. Win was 7 and 11, lose was 5, 8, and 13, and try again was all the other numbers. If a win or lose was obtained, if a win was obtained, the green LED over here would light up. If a try again was obtained, the green LED here would light up. And if a lose was obtained, the red LED here would light up. If the try again was obtained, then the user would need to press the roll button again. When the roll button was pressed again, this was sent to the RNG module to generate another set of numbers. And the adder module would sum those numbers, and then the new sum of the numbers when the roll button was released would be obtained. The point register module, if try again was obtained, the point register module would save the old sum that was obtained before the roll button was pressed. And then this old sum would be compared with the new sum that was generated. And if the sum was equal, you would get a win. If the sum was different, you would get a lose. So this can be seen. It was, remember, the seed was for 7. So I put the reset to 1, 0. Then I press the button. Sorry. And 4 plus 7. 4 plus 7 is 11. So we directly got a win. 5 plus 6 is 11. Directly got a win. 8 plus 3 is a 13. So you directly got a loss. Since the A plus 3 is 13, and you directly got a loss, if you press the button again, since it's not, try again was not initiated, the button won't change the number. A new number would not be generated. To check the try again sequence, D plus DB would be 13 plus B was 11, so it will be a 24. So then when I press the button again, it's a 9 plus F. F is 15. 15 plus 9 is a 24. So it was the same, so it got a win. B plus 2, 13. B plus 3, 13. And plus 7, 8. 13 again. E, D. E was 14 and D was 13. So 14 plus 13 is 27. Then 5 plus 6 is 11, so it's different, so you got a loss. So that's all for the demonstration today. Thank you very much.